Hey guys, welcome back to this lecture storage. In this lecture, we will learn about storage. We will see what are the components that makes the storage and how does those works. And also we will see the storage structure in our Linux machine where we have actually implemented the Prometheus. So we will start with the theoretical part first. We will understand the concept here and then we will look for the actual file structure which is implemented for the Prometheus. Okay, now we'll start with the very first thing that we need to know is by default Prometheus uses local on-disk time series database, means local stores or your Prometheus stores the data in the form of files which is stored in your local hard disk. Now, second thing is ingested samples are grouped into blocks of 2 hours. So every block of 2 hours contains further directories and files like chunks directory which contains your chunks data. Okay, so every 2 hour block consists of a directory contains a chunks subdirectory which actually contains your time series samples for that window. There would be a metadata file and an index file which indexes metric names and labels to the time series in the chunks directory. Okay, now samples in the chunks directory are grouped together into one or more segment files. So inside the chunk directory you might find one or more than one files. Each could be up to 512 MB by default. Okay, now the current block for incoming samples is kept in memory using write-ahead log. Write-ahead log files replace when Prometheus restarts. Means the latest block of last 2 hours is not stored in the hard disk permanently. It first stores in the memory in the form of write-ahead log files, and it helps or it secures the Prometheus from the crashes. Now suppose the data is getting ingested in the Prometheus, all of a sudden Prometheus stopped or Prometheus crashed. So what happens when the Prometheus comes up again? It reads those last 2 hours of block or 2 hours of data from the write-ahead log file, and it syncs the data and then it continues. So it basically secures the data Prometheus against the crashes. Okay. Next thing is well files or write-ahead log files are stored in well directory in 128 MP segments. These files contain raw data that has not been compacted, which makes it significantly larger than regular block files. So you need to know about it. So the regular block files that are having the samples, those are compacted, so the file size is significantly lower. But in case of well files, as it contains the raw data and it is not compacted, the size could be significantly higher than the other one. Okay, the next thing is Prometheus retains a minimum of 3 well files, but in case of larger systems, there could be more than 3 well files. So the concept behind is like well files is supposed to be stored 2 hours of data. So if there could be multiple well files as well to support that concept or support that 2 hours of data. So this was about the storage in the theory. Now the next thing we need to know, how does it actually look like in the Prometheus implementation? And we will take an example of our Linux machine where we have set up the Prometheus and we will see the storage over there. So let us jump onto the other screen. Okay guys, so on the screen you can see I'm in my Linux machine where we have implemented the Prometheus. Okay, so I will go inside the Prometheus directory where we have copied and implemented that. So I'm inside my Prometheus directory in the root path. Okay, now I need to go inside the data directory here. Inside the data directory, you will see these are the 2 hours of block. Okay, now this is the write-ahead log file. This directory basically stores the chunks head, which helps it to create the checkpoints and sync the data. Okay, now let us go inside any of the 2 hour block directory. Let us go inside it and let us see here. So in this particular directory, we have further directories and files. The first is chunks, which basically contains your actual raw data of samples. Okay, time series samples. Index file, which indexes your chunks or samples that are coming along with your labels to the time series. This is the metadata file in JSON format. This is the tombstone file. So whenever you delete any time series using API manually, so those are not immediately deleted. Those are stored in the tombstone files. So this is how it looks like. Okay, now inside chunks you can further see. So this is one file where it has written the time series data. Okay, so this was about the file structure in the Linux machine. How does it looks like? And here we will wrap this lecture, and in the next lecture we will see what are the other details we need to know about the storage, and what are the limitations with it. So I'll see you in the next lecture. Thank you.